What's up, YouTube? Just taking a look at a failure that I had back in over the summertime, actually. So if you remember the motor test stand here, I've got the gearbox there with the motor, encoder, motor controller, and hooked this up and was running it from my computer. And you saw some videos of that in my channel over the summertime. This is the gearbox that was in there. And I ended up not making a video about it, but it failed after only a couple of minutes of operation. It failed really, really quickly. It was not an improvement in the design. And I am finally taking it apart because I have a new gearbox design right here, which I'll show you in just a moment. But the plan for this gearbox was to use metal pins instead of a plastic boss that came off of the gear. So in the original design, excuse me, reaching, the gears were like this. So in the video where Rover goes 2 kilometers and the gearboxes fail, this is what was inside. And then there was parts of the gearbox on the inside that look kind of like this, but that was just a hole. And so the plastic pin there went into a hole on the gearbox. And when that failed, I said, okay, well, let's use metal pins. But you can see here, these are totally hosed. Remember, this is the old design. I'm going to show you the new design in a minute. I really think that I've got something that's going to work. So the problem with those big pins was that they left very little wall thickness here. Here is an intact gear from the second stage, but the pin did pull out. But you know, the wall was so thin that the gears, as soon as they were experienced any force or pressure, they just deformed. And then this thing failed really quickly. So I've changed that. So instead of this design and this other design with the metal pin here, the gear was just sticking into a hole. And now I've got really a much improved design. So this is the new gearbox design that I'm working on. And huzzah! What do we have here? So this is what would replace, actually, let's see. So this is the first stage. And this would replace, let's see, basically you would have metal pins like that, and they would go sort of into there, and that would be on the planets, and so these would be like the first stage. So these are like the same part from the old design versus the new design. And so you can see some big changes here. So in particular, there's a steel shaft going through there, a 3mm steel shaft, and then a bearing on each side, and then there's also a small washer spacer there. But now these gears are like appropriately constrained, so they don't have any angular wobble because they're supported on both sides. This feels really sturdy, and it rolls really nicely. And so this is the sun gear, and the motor engages with that pattern that you see in the center. And so this would go like that. Of course, on camera it's going to be a little tricky. There we go. It's easier when you're not doing it one-handed. But I mean, it really, this is way better than what I had before. So it moves really effortlessly. And then I adjusted the tolerances because I was making the gearboxes too tight. I don't know why. It was just like I was pounding the gears in and thinking that was somehow fine, but I had a tolerance off either on the software or on my printer. Fix that. So now, hard to see here. Yeah, a little awkward to do that. I'll have some more videos of its operation. And then so here's the next stage. There we go, and I just printed a little T-handle that goes in the spline that the wheel would normally go into. And there, that's it. And it's not really going to do it. I tried it one-handed before, but two-handed, if you just hold it with even load, then this thing actually backdrives really nicely. It's pretty cool. Another major change you'll see here is that these gear assemblies come straight out. On this design, I saved a little bit on the diameter here, and I actually just left a little bit of area for assembly. So on the first stage, the gears go over and down like that, and then on the second stage on this design, you'd have to rotate the gears to this position to insert them. And when the gearbox was damaged and it wouldn't rotate like this, assembly was very problematic, so I actually had to cut these apart in order to remove them. And on the new design, yeah, it just comes right out, and that's got to be the way to do it. So I'm going to change the design of the future so that there are not mounting holes on the inside of the gearbox. That's going to help me. I'm actually going to be able to make this a smaller diameter, because this could easily be a smaller diameter, except that I still need those mounting holes to screw to the existing Rover chassis. So next time I feel like printing a new chassis, I'm going to change that and shrink this gearbox. Anyway, this is the gearbox that basically the last gearboxes went about 1 kilometer before they failed, on average thereabouts. 3 out of 4 failed after 2 kilometers. That was in July, and I've been working on a lot of different things. You've seen the software project. Been working on a lot of different things, but I am about to put this new gearbox on the motor test stand, and I wanted to do a proper post-mortem before I got too much farther. That's this video. It's done. Now I'm going to pull this motor off and get things hooked up to this. Thanks for watching.